So I was asked today in class about a particular property of logarithms that basically says if I have some logarithm with an exponent involved in it, then what I can do is I can take that exponent actually out and make it sort of like a coefficient in front of the logarithm, just like that. And what's kind of cool about this is that as long as your base is some positive number and not 1, then this kind of works. And so most of the time people will automatically assume k is a constant, but the cool thing about this is it doesn't matter what k is. It doesn't matter what that exponent is right here. It could be a trig function, it could be something involving x's, it could be quite literally anything, and this property will still work. And so that kind of makes this really nice. Even this doesn't have to be just x. It could be a sine of x. It could be any number of different functions, any number of different things in there, but this property still does work. And so I'm going to kind of demonstrate this using a very specific example, and I'll show how this works. So I'm going to start off with y equals log base 5 of x cubed. And so all I'm doing here is starting over here with the left-hand side, and I'm going to show using algebra that it's actually equal to the right-hand side, or what I would expect for the right-hand side. And so the first thing I'm going to point out is if I change this logarithm to an exponential function, it's going to be base 5. So let me go ahead and do that. 5, and this right here is going to be my exponent. Whoop, didn't mean to get rid of the 5. And this equals this expression in the parentheses, which is x cubed. Now, from this logic, I want to solve for x there. And in order to get rid of the cubed, we're going to cube root it. So I'm going to do the cube root of 5 to the y equals the cube root of x cubed. Now, the cube root and the cubed will cancel out, leaving me with just x on the right-hand side. And on the left-hand side, I'm going to rewrite that as 5 to the y to the 1/3. Now, hopefully you guys remember that anytime you have a radical, that it's actually a fractional exponent. So even if it were a square root of x, that's x to the 1/2 because there's this little 2 in the index. Or if you had the fourth root of a, it would be a to the 1/4. That's how these radicals work. Um, but so what I'm going to do now is I'm going to multiply these exponents, because a power to a power, you just multiply. So we're going to have 5 to the 1/3 times y, which is y over 3 equals x. Now I'm going to convert this back into logarithms. And so this is still going to be my base, the base 5. And so I'll write that down, log base 5. And the expression that it's equal to is the x now, just x. And the exponent is y over 3. So if I want to solve for y one last time, I would multiply both sides by 3, and that gives me 3 log base 5 of x equals y. Now, both of these are equal to y, which means that this expression and that expression are the same. So it is true to say that log base 5 of x cubed equals 3 log base 5 of x. And this is going to work no matter what. So again, if there's an exponent up here, you can pull it out and make it a coefficient instead. And that's going to be true again no matter what. So hopefully this helps you guys better understand where this property of logarithms came from. Let me know if you have any questions. Bye.